happy atom presentation 2 by Geraldine. Trichromatic hydrogen, or H3. Trichromatic hydrogen is very unstable, though because of its short lifetime, it's rare, because it's commonly made in the universe. It's also commonly destroyed in the galaxy, thanks to the commonness of trihydrogen cations. In 1911, J.J. Thomson thought that H3 was stable, so he documented it and taught about it.
Oh, man. Did he blow somebody up?
I don't know.
He's not with us anymore, but we don't know if it was old age. Okay? Well, we may want to track down whether he's...
And this molecule can only exist in an excited state.
So, okay, so that's pretty cool. You made the picture.
State.
An excited state.
What does that mean?
Do you know what that means?
I know people like that.
Hey, I resemble that comment. All right. Who says demo day's boring and without humor? All right. So you made that picture. You made the happy atom. Okay. Very cool. Triatomic hydrogen. H3. 3 hydrogen atoms. Okay. Hydrogen's pretty unique, huh? All right.
Disylene. Si2H6. Disylene can be found.
Si2H6. What is Si?
Silicon.
And H is the
H is
hydrogen. So okay. So now I see the picture. You got 2 silicon atoms connected with a whole bunch of hydrogen.
6 hydrogen.
And that's okay. Okay. So wow, the 2 silicons are connected together with. That's interesting. Okay. Bunch of hydrogens all over the place.
Disylene can be found on circuit boards and in your phone and computer.
Well, now why would that be? What about SiH6 would be good with phones and computers?
It slowly blows up.
No. Silicon is where?
It is
Is it a metal?
No.
Is it a non-metal?
Yes.
Or is it something else?
The metal.
I don't think so.
You're sending mixed signals.
I believe it's a metalloid. Is it a metalloid? What is interesting about metalloids?
They are sort of insulators and sort of conductors.
That's right. And that's exactly why they're used in circuit boards, because they are semiconductors, right? And silicon is what's unique about silicon on this planet? It's the most plentiful semiconductor there is. So we can make lots and lots of things with it, like billions of cell phones. Great. But anyway, keep
Disylene
going.
is also used in the production of silicon wafers, though it is flammable.
Ah,
Disylene is usually prepared by the
hydrolysis.
of magnesium silicide.
So they took magnesium, which is over there on the alkali earth metals, right? Which is sort of reactive, but not as reactive with water. And that attaches naturally with silicon. They put it in water, and that releases the bonds and works on the magnesium to then give you this silicon, this disylene. Does that make sense? Remember, because of the properties of the earth, the alkali earth metals, and how reactive they are, especially with things like water. That's why the hydrolysis, that's how they can make a different compound. By taking this magnesium silicate, which they find, throw it into water, then it creates this purer form of silicon, which is this disylene, if that's the name of it. I'm not sure if that's how you pronounce it. But then that more pure form allows you to use it in electronics. It becomes better conductors and this whole thing, right? It's more of a pure form. Cool, right? Mm-hmm. Yeah, neat.
This reaction produces silane, disylane, and even trisilane.
Which would be, what would that look like? What would be trisilane's compound? Probably. Cool, right? So there's a relationship between the number of hydrogens a particular other element can absorb, right? Silicon and carbon are unique in the sense that they can make massive chains of that stuff. And each chain link is something different.
I wonder if it's pronounced disilane.
Disilane, trisilane.
Yeah.
Yeah, that'd be cool. Yeah, it might be worth validating the pronunciation before you have the presentation, but that's just a minor thing. Got it?
Ammonia, I think is what it's called.
Yep.
NH3. Ammonia is a compound of nitrogen and hydrogen. Ammonia is also a fertilizer that helps plants grow. It is the highest nitrogen content among fertilizers. It's also a key ingredient in some household cleaners. It's also flammable.
And it's also used in bombs. So people will take a whole bunch of fertilizer and they try to blow up.
Other people that they don't like.
That's true. Other people they don't like, and they tried to blow up particular buildings in the United States with fertilizer bombs. Crazy.
Because their business is destroying the other.
That's true. That's true.
Nitric acid, HNO3.
Oh, so we got 3 different elements in this thing, huh? What are the 3 elements that we have here?
We have oxygen, nitrogen, and hydrogen.
Sweet.
Nitric acid is used with ammonia to make fertilizer, though it can be a health hazard to humans. Nitric acid can oxidize non-active metals such as copper and silver. The pure compound is colorless, but older samples tend to acquire a yellow cast.
So it's kind of interesting. They said they can make is used with ammonia to really juice up the amount of nitrogen, right? Because it's got nitrogen in it too. Nitric oxide can oxidize, can oxidize what? Non-active metals, such as copper and silver, so transition metals. So when it oxidizes non-active metals, what does that mean? What's another word for oxidation? You can scrape it off a piece of metal sometimes if you leave it outside. It's brown stuff. If you leave a piece of rust, that's oxidation. So rust is a form of oxidation of iron, right? So if you throw nitrous oxide on iron, you'll rust it out. And is rust strong like normal iron? It's brittle and dusty and destroys its capabilities. So this nitric acid can destroy iron.
So that's why rusty shields and things.
That's right. Exactly. It becomes brittle. Someone poured a bunch of so if you could hurl nitric acid on Link, then his shields would turn to dust.
Is iron non-active metal?
Yes, iron is a transition metal, which is what you consider normally about what you think a metal is.
Silica, SiO2. Silica is a common part of sand. It makes the sand resistant to weathering. It's also used to make glass and ceramics. Most things in the sand in the world in silicon dioxide in the form of quartz.
Very cool. We're going to grab quartz. We're going to put quartzite in the kitchen in the place, right? And what's interesting about this is if you have iron oxide, that's rust. So it's like it is weathering, right? But with silicon, a metalloid, not a metal, but a metalloid with oxygen makes it resistant to weathering because of the oxygen is doing what in this case? It's protecting it. Look how it is. Look how the oxygen is shielding it. Remember how we talked about how things can be transported in with non-metals? You can transport metals and reactive things like sodium. You can transport in a layer of non-metals so it doesn't react. Otherwise, if you open it up, it's going to go boom and blow up, right? So you transport in. Yeah. So it looks like here. So this silicon oxide, you have to break that into, what was the first thing that you had? The disilane.
Yeah.
So you have to take this and turn it into disilane to be able to make it into a chip or second thing. But it makes it, that's how you make the chips, right? is start here, then go to the next one.
Silicon carbide.
Whoa,
S1.
this is radical. Well, wait a minute. You've got an MG in there.
Yeah, that's the wrong.
Oh, yeah, I think I got it.
That thing is wicked looking.
So silicon carbide.
Well, I think you got the wrong picture
I
here,
think-
right?
Yeah, we think the
Oh,
picture.
yeah, I
might
think
be
I
wrong.
accidentally got
That's okay. What, do you have the right picture?
probably.
I want to know what that thing is. Forget the silicon carbide. I want to know what that crazy thing is with the magnesium. Do you actually have that compound?
Yes.
Oh, where's that compound? How are we doing on time? We got 11 minutes. All right, I'm going to stop here and we can